Hello everyone, welcome to our channel. In this video we are going to solve a problem from 2016 in JAM Biotechnology paper. Here the question is, in a PN junction the depletion region has a width of 3 into 10 to the power minus 7 meter and the intensity of electric field in the depletion region is 10 to the power 6 volt per meter. An electron approaches the junction from the n side with velocity v1 and enters the p side with velocity v2. If v2 equal 4 into 10 to the power 5 meter per second, the value of v1 is option A 3.2 into 10 to the power 5 meter per second, option B 4.2 into 10 to the power 5 meter per second, option C 5.2 into 10 to the power 5 meter per second. Option D 6.2 into 10 to the power 5 meter per second. Given data, charge of electron equal 1.6 into 10 to the power minus 19 coulomb, mass of electron equal 9.1 into 10 to the power minus 31 kg. Okay, so we have a PN junction, that means a PN junction diode. Okay. So here is a P region and here is a N region, okay, and between them there is a depletion region created. In between these two sides, P side and N side, there is a depletion region, okay. The width of the depletion region is 3 into 10 to the power 7 meter. So let us call it as D. Okay. And the intensity of electric field in the depletion region is 10 to the power 6 volt per meter. Okay. So let it call as E, the intensity of electric field. Okay. Now an electron approaches the junction from N side. So suppose here is an electron which approaches the junction from N side, okay, and inside with velocity v1, so its velocity here is v1, enters the p side with velocity v2. So it has the ability, or this electron is capable of crossing the depletion region. That means this electron has enough energy to pass this depletion region, so that it can enter the p side via the depletion region. So here at the p side its velocity is v2. Okay, so the electron starts from inside, crosses the depletion region and enters the p side. Okay. So we have the velocity v2 equal 4 into 10 to the power 5 meter per second, and we need to find the value of v1. Okay. So see, why or how can this electron pass this depletion region? As I said before that it had enough energy with it, so that he can pass through this depletion region of width 3 into 10 to the power minus 7 meter. He could go through this intensity of electric field. Okay. Now if here if the depletion region has this electric field here, if its width is 3 into 10 to the power minus 7 meter, then the potential difference potential difference between these two sides, the potential difference between these two sides is suppose V. Okay, then we know that V is equal to E is equal to V by D. I hope we all know that the intensity of electric field is equal to the potential difference divided by the width of the depletion region. Okay, if you don't know the equation, if you don't know the formula, then remember it. Okay, keep it in your mind. E equal V by D. It's a very important formula for this type of questions in this p-n junction depletion region. Okay, so equal V by D. So from here we can write V is equal E into D. Okay. Now, as I said previously that the electron had enough energy to cross the depletion region. That means we can write that the electron had energy initially K1. Okay, kinetic energy. With kinetic energy it can pass through the depletion region, right? So its initial kinetic energy is K1. So the one part of this energy K1, a part of this energy is wasted to cross this depletion region. How it is wasted to cross this depletion region? It is wasted as EV. Okay, so the part EV, that is E times V, that is E here is the charge of electron, that is 1.6 into 10 to the power minus 19 coulomb. This is the E. Okay, and V is the potential difference between the two sides, that is P and N side. The potential difference is V. So E times V is the one part which is wasted to cross the depletion region, and the further the excess energy, which is rest energy. Okay, the excess energy which is the electron have now is suppose K2, the kinetic energy. Okay, so it is left, this K2 is left. So we can write this that K1 is equal to EV plus K2. Okay, where K1 is the kinetic energy or the initial kinetic energy of the electron, and K2 is the final kinetic energy of electron. So K1 we can write it as initial kinetic energy of electron, and K2 is final kinetic energy of electron. Okay, now what is this K1? K1 is the kinetic energy, that is and what is the formula of kinetic energy? Kinetic energy we know is half mv square. So since here V is V1, so we can write K1 as half mv1 square equal EV plus K2, that is half mv2 square, because here the velocity is V2. Okay, so K1 equal EV plus K2 implies half mv1 square equal EV plus half mv2 square. Here this m is the mass of electron, that is 9.1 into 10 to the power minus 31 kg. Okay, this is the m. All right. Now this we have this E, M and also V2. We have V2. Okay, we don't know the value of V1, we need to find it. Now one thing we don't know, that is the value of this, V, okay, this potential difference. So to find the potential difference, we need to use this relation, that is V equal E into D. So we can simply replace here. So it is small e times capital E into D plus half m V2 square. This is equal to half m V1 square. Okay. So if we simply divide both sides by half m, we get V1 square equal 2e capital E D by m plus V2 square, since we have divided two sides by 2 by m, okay, that is half m. We have divided both sides by half m, that is we have multiplied with 2 by m. We have V1 square equal to small e into capital E D by m plus V2 square. Okay. Now let us put the values of these. So we get V1 square equal 2 times small e into capital E into D by m. So let us do it in the next page to be very clear. Okay, so we had V1 square equal to small e into capital E D by m. V1 square equal to small e capital E into D by m plus V2 square. So if we put the values of each, so 2 into, see here, small e is 1.6 into 10 to the power minus 19, capital E is 10 to the power 6 volt per meter. Okay. 1.6 into 10 to the power minus 19 into 10 to the power 6 volt per meter. Okay, into D, that is 3 into 10 to the power minus 7 meter. Into 10 to the power minus 7 meter divided by 9.1 into 10 to the power minus 31, because the mass of electron is 9.1 into 10 to the power minus 31. Okay. So now V2 square. What is V2? V2 is 4 into 10 to the power 5 meter per second. So 4 into 10 to the power 5 whole square. Okay. So it becomes, if we calculate it in our calculator, we need to use our calculator for it, because without the calculator it's very tough to calculate. So it becomes, first simplify it by our own. 1.6 into 2 is 3.2 into 3 divided by 9.1 and take the powers of 10 separate, that is 10 to the power minus 19 plus 6 minus 7 plus 31. Okay, plus it is 4 plus 10 to the power 5 whole square, that is 16. 4 square is 16 into 10 to the power 10. Okay, so it becomes, if we calculate this, that is 3.2 into 3 divided by 9.1, you can do it in your calculator, then we get it as 10 point, okay, let's do it. 3.2 into 3 by 9.1, it is 1 1.055, okay, into 10 to the power it is 19 plus 6 minus 7 plus 31, so it is minus 20 plus 31, that is plus 11, okay, plus 16 into 10 to the power 10, okay. So it is equal, if we take 10 here, so it is 10.55 plus 16 into 10 to the power 10, okay, that is equal 26.55 into 10 to the power 10, and from here we can get V1 equal root over this, that is 26.55 into 10 to the power 10, that is equal, if we do it in our calculator, because without calculator we can't do it, so it becomes root over 26.55 into 10 to the power 10, that is equal 515,266.9, okay. So our answer is in 10 to the power 5 format, so we can write it as 5.15 into 10 to the power 5 meter per second, okay. So it is our answer. Now let's see the options. So we got 5.15, so our options doesn't match except this one. Here is 5.2 into 10 to the power 5 meter per second, so it is the approximate answer, that is option C is our answer here, 5.2 into 10 to the power 5 meter per second. I hope I hope you understand this solution. If you have any further query related to this solution, you can tell me in the comment section. If you like this video, please click on the like button, share this video with your friends, and if you are a new viewer, then don't forget to subscribe our channel. Ta-da!